This is Mr. Bovenreith, and in the next few minutes, I'm going to walk you through how do you create a min-max gradient analysis on Google Sheets. Now, for this video, we are using a data set from Investigation 3-2 in first year physics, the Newton's second law investigation, but this could work for any sort of data set. The first thing I'm going to want you to do is I'm going to want you to take this data set and open a new worksheet. The way you open a new worksheet is you click Add a Sheet on the lower left corner. And I want you to copy the data set that you want to use. So I'm going to do that, edit copy or Control C, go to that second worksheet, go to the top left, hit Control V, and notice if you get this sort of error, then go back and do it one more time, but go up here, hit Edit, Paste Special, Paste Values Only, and that should fix any errors you got in that sort of transposition. Okay, so the first thing we need to do is we need to create a graph of our two variables. And in this case, it's 1 over system mass and average acceleration. So I'm going to highlight those. I'm going to go over here and click Insert Chart. Notice I get a column chart. We know we don't want that. We want to come down here and do a scatter plot. And we also want to make sure that, let's size this appropriately. There we go. Want to make sure, notice this happens sometimes. If this happens to you, notice there's no x-axis values. So Google Sheets has interpreted that you've asked it for 2 y-axis values. So all you have to do is go to click Add X-axis here and indicate the data you want. The data is right here, A4 to A10 in my case. Make sure you carefully look at what the cell range is for your data set. So I click A4 to A10, and then I come down here to the series, which is my y-axis values, and I remove that because I only want A4 to A10. Awesome, so that's looking better. Now, let's quickly make sure we label this appropriately. So we want to customize chart and axis titles. We have a chart title already, which I'm not crazy about. I'm just going to leave it because that's not the main purpose. But horizontal axis, our horizontal axis is 1 over the system mass, 1 divided by system mass. And those units are kilograms to the -1. And then on our y-axis, vertical axis, we have average acceleration, which is in meters per second per second. Okay, very good. Now, we need to apply error bars. And the first thing we want to do then is we want to go to our customize legend, and we want to go to our series here. One other thing we're going to do while we're doing this is we're going to change the point size here to 2 point of our little actual plotted points. That'll help us see our error bars better. And I'm going to change the color to make it just a little easier to see. So I'm going to make it this darker blue. And then we want to add a trend line, as you can see there. And for the trend line, we're going to want an equation. So we'll go down here, label, use equation. And then remember, error bars tell us the uncertainty in each of our data points. So we're going to click on this little error bar box, and you should have already determined what sort of constant error bar you want to use. In my case, I have decided, based on my data set, to use 0.18. So down here where it says type, I'm not going to use percent, I'm going to use constant. And instead of 10, I'm going to type in 0.18. Notice I get error bars that look like that. Great. Now, a min-max gradient. Remember, the goal of a min-max gradient is to give yourself and give any reader a sense of the uncertainty in their data set. You have a trend line, a slope of 1.17, but that's 1.17 plus or minus a certain amount. So what you want to do is you want to use these columns here, and you want to use the power of a spreadsheet to give the reader and give yourself a sense of how uncertain is that 1.17 slope number. So we're going to construct 2 more lines. 2 more lines. One would be a max gradient line. And I'm going to create a column heading here called max gradient line. And the next one would be a min gradient line. Okay, awesome. So I want to refer you now down to this little box at the bottom here where it says, where I've given you some information from a recent IB publication. I'm just going to read it out loud. It says, just as data points naturally scatter above and below the regression line, so too can minimum and maximum gradient lines follow paths that do not necessarily include the range of any given error bar. However, a reasonable construction of the minimum and maximum lines will include most error bar ranges. That is, when constructing the minimum and maximum gradients, students must appreciate the scatter of all the error bar ranges, but this only means that most error bars will be included in the path or the range lines. Now, I suspect some of you are saying, whoa, Mr. Bob, how do we interpret that? And I'm going to kind of walk you through that. So let's first get a couple of data points on our graph, so that we can create and kind of fiddle with a max gradient line. So for this max gradient line, notice for system mass of 1.82, I have an average acceleration of 2.13. So to get a max gradient line, that means I'm going to have to be steeper. That means I'm going to have to be up on this upper end of this little error bar that I'm pointing the cursor to. So to me, I'm just going to eyeball this, and this looks to be about 2.3 maybe, or 2.2. So I'm going to put 2.20 in right here. And then over here at this data point right here, a max gradient line is going to kind of pass through this region down here. So that's probably going to be close to 1.00. So I'm going to put 1.00 down here. Okay, then I'm going to create my graph of my max gradient line. To do that, I'm going to go over here. I'm going to click Edit Chart. Notice I have this little spot down here which says Add Series. I'm going to click on this on the right-hand side here, and I'm going to indicate it to create another data set, and this would be D4 through D10. So I'm going to write D4 colon D10. You could also drag and highlight it. It's your choice. Notice I've got a different color now, and I've got 2 dots, and that's all I need. That's all I want, really. So I'm going to work with these 2 dots. So I'm going to go to Series, and I'm going to first make the point size 2 point as well, because I'm not really so cared about the dots. I want to look at the trend line. I want to create a trend line, and I want to have an equation for that trend line. Awesome. And now here's where I have to apply that sort of IB jargon that I read to you recently. So notice I'm looking at this max gradient line, and notice it's supposed to take into account or go through the error bars in most, if not all, the data points. And right now, the points that I arbitrarily selected didn't do a bad job, but it looks like this seems like I'm going beyond the error bar here on the bottom and beyond the error bar here up above. So it seems like I need to make it a little less steep. So in order to do that, I'm just going to change one of these points, and I'm going to move this one up, the 1.00, I'm going to make 1.10. Notice what happened there. Instantly, in the power of spreadsheets, the slope of this line changed. And you can see here, now I have to evaluate it again and take a look at it. Is this line adequately represent the full range of the error bars that I have for this data set? And I might just make a little bit of an adjustment here. I might make this 2.17. And so when I do that, this looks pretty good. I could keep fiddling with it, but I think for the purposes of what we're talking about here, well, maybe I'll make this 2.18, and maybe I'll make this 1.09. It's your choice how much you sort of mess with it, but I'm going to stop there. Notice I have now my max gradient line, and you can see here this reddish line goes through and accounts for the uncertainty in my data. So I'm telling the reader and myself that even though the best fit line is 1.17, it could be as high as 1.33, that slope of that line. Now let's do the same thing, but for min gradient. So for min gradient, that's going to be the opposite. On this end, I'm going to be up around, for this data point of 1.00 of the inverse of the system mass, I'm going to be up around probably 1.30. I'm just going to use that as my starting value. And on the bottom side, or over here on this end, I'm probably going to be right around 1.95 is my guess. So I'll put those 2 numbers in, and again, I'll go over here to Edit Chart. I'll add another series, and I'm going to do that for E4 through E10. Notice I do that by dragging this time. And whoa, I was way off on that. And this is fine. This is what's wonderful about this is let's first customize this, go to Series. We want the point size to be 2 points, and we want data series 3. We want a trend line for it, and we want an equation. This is way off, but that's okay because, again, with the power of spreadsheets, and I'm not sure the orange color is going to look all that great or show up all that great, so I'm going to go with the darker green. Okay, so let's start changing these numbers. So I was way off on this. So, oh, I know what I did. I kind of reversed this, didn't I? I did. So this should be 1.95, and this should be 1.30. Yeah, now I'm closer. Um, so you can see here as I evaluate this, what do I see? Well, this still really doesn't take into account, it's way too, this, by this point over here, all the way on the right, this green line is way out of bounds and doesn't really account for its this error bar here. So I need to, what do I need to do? I need to move up this end. So in other words, instead of 1.95, it needs to be something like 2.0 maybe. I need to go up a little more. I would say 2.15 maybe. Oop, that's too much, I think. So maybe this is 2.09. So if I do that, notice now I've got that green line looks like it maybe accounts for all the error bars on all my data points. And so notice what I have here, and I could tweak this a little more, maybe on this end. I could make it 1.32 maybe, or maybe even 1.33. Okay, then I kind of like 1.32 some more. So you choose how much you want to do that. So notice what I have now. I have a graph where I've created a line of best fit. I've added error bars to that line of best fit. And then I have gone through this process where I have estimated what is reasonably the maximum that slope could be, and that's 1.33, and what is reasonably the minimum the slope could be, which is 0.94. And so this is a min-max gradients analysis that we've done. Now, the final step, you don't want to miss this, is you want to make sure that you have a sort of, you get the data, you get the information that you need to. So I would want to write something in my conclusion that would kind of summarize what this is. So we could say the line of best fit has a slope of 1.17, and I would want to use the units. In this case, the units are newtons. But the plus or minus, this is where the min-max gradient really comes in handy, because what you're going to do is you're going to do a min-max, max minus min divided by 2. So I'm going to do 1.33 minus 0.94. 1.33 minus 0.94. When I do that, I get 0.39, and I divide that by 2, and I get 0.195, which I can round up to 2.20. So plus or minus 0.20 newtons. Okay, and that's the whole point. And we could even write that as a percentage, and that if you convert that raw uncertainty into percentage, you get that the slope is 1.17 newtons plus or minus 15%. Okay, and so that's the end result. What you want to get out of this is a sense for how uncertain is the slope of your best fit line. I hope this has helped you. And of course, I always have a pun for students. So here's my pun. What did the ice cube say to the glass of water? I was just like you before it got cool. Ha 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 ha. All right, have a great day, students, and I will see you soon in the classroom.